right? Just go with me one time.
Anywhere,
Get in the car.
I don't want to go anywhere.
All right, just go with me one time. Hey, what's going on here? Let's come talk about it. There's nothing going on.
Charlie 2, I've been shot. Start my priority backup.
This is an all too familiar event in the modern world. In fact, this one's an exercise. A SWAT team training for the day when they'll have to do it for real. And real events happen somewhere every day.
This program looked at how those events can happen at all, but not at the hostages or the criminal plan, at the fact that what puts all the pieces together, the guns, the explosives, the computers, that chopper up there, and to start with, the anesthetics waiting in the ambulance for this injured officer, what puts all the pieces together is history. Because history is all about getting it together.
In 1783, two French brothers called Montgolfier amazed the world with the first human flight. By 1800, hot air balloons were the space satellites of the day, doing spy flights and weather watch. Then in 1875, a doctor called Paul Bert, interested in why the newly discovered laughing gas sent people unconscious, realized that doing this did too. Now, surgeons needed to know how to knock people out for specific lengths of time. So Paul Bert started experimenting on high-altitude balloonists, concentrating above all on their consciousness
and how they might lose it. So for 7 years, he ran trials on himself to see what the effects of different gases would be, and he discovered that what mattered wasn't how much gas there was, but what pressure the gas was at. So he tried an anesthetic mixture, 5 parts laughing gas, 1 part oxygen, at 1.5 times atmospheric pressure, and he went unconscious. But he came to again, so he was obviously on the right track. What he needed now was an oxygen pressure field trial under survival conditions, at high altitude.
Bert sent up a couple of volunteers carrying bags filled with oxygen to breathe when the high altitude caused them to start to black out. And it worked. Well, half worked. The one guy who went ahead and did it came back to a tumultuous reception. Bert now had all the data he needed to go ahead and invent anesthetic gas and take the world of surgery to new heights of expertise, the prospect of which was, for his colleagues in the medical profession of the time, music to the ears. Meanwhile, back to the Montgolfier brothers. One day in 1795, one of them, Joseph Montgolfier, had a great idea for upgrading the royal amusements, which, amazing as it seems, you're looking at. The Versailles Water Gardens, hydraulic engineering back then being the last word in gee-whizzery.
Now, you're not going to believe this, but back then, the way aristocrats had fun was by squirting water about. So Montgolfier's idea fitted right in. Worked just like this toy. You compress air so that it builds up behind a water reservoir, and then when you release the water, this happens. Montgolfier compressed his air by dipping the whole contraption in a stream. The faster the stream, the more it compressed the air, the harder it rammed the water. So he called it his hydraulic ram. Just the thing for irrigation, canals, water gardens, fountains, and squirting aristocrats. Ho, ho. 50 years later, Montgolfier's water squirter sets in train something rather boring. See, mid-19th century, the king of Sardinia, who happens also to be king of a lot of northern Italy, decides it's high time he does something about his province of Savoy, stuck on the wrong, that is, the north side of the Alps. And besides, the entire European railway system and most of the roads stop at the Alps, depriving the king of lots of lovely tourist money.
So in 1857, they started boring a tunnel under the Alps. The work involved standing round while people hand-drilled holes for explosives and blew them up. Then you dug. 15 inches of tunnel a day was all they could manage. Until the chief engineer brought in a version of Montgolfier's hydraulic ram to compress air for pneumatic drills, and they started doing 15 feet a day. The breakthrough handshake came on Christmas Day 1870, and it was champagne all round. Cutting through mountains became even more fun when somebody invented dynamite. So by the turn of the century, there were 3 tunnels under the Alps, and a new, luxury way to get to Istanbul.
On the Orient Express. Now, by an extraordinary irony, the 3 chief engineers building all 3 tunnels died of heart attacks. The irony being that the nitroglycerin they were using could have saved them. See, before dynamite, the main use for nitroglycerin was as medication to relieve the symptoms of a heart condition, because in one form, nitroglycerin opens up the constricted blood vessels that can lead to a heart attack. There was one other less drastic medical use for nitro. It was discovered that handling dynamite every day could give you what was understatedly known by doctors at the time as a dynamite headache, relieved by taking nitroglycerin. Until, that is, things took a turn for the botanical. This little plant's called meadowsweet. And back in 1835, a French chemist had extracted some stuff from it called acetyl salicylic acid. Found out it would cure headaches, but the process took so long he gave up. Anyway, the botanical name for meadowsweets, Spirea ulmaria. Now, a few years later, when every German chemist was going nuts trying to extract anything they could find from the new Wundergunk throwaway byproduct of gaslight, coal tar, one of them came across a chemical called phenol with which you could artificially make acetyl salicylic acid quick and fast. So he made up a name for it. A for acetyl salicylic acid, S-P-I-R from the botanical name for meadowsweet, and nobody knows why he chose the last 2 letters, I-N. And that's why aspirin's called aspirin.
From 1899, when aspirin first went on the market, headaches would never be dynamite again. Meanwhile, don't forget the name of the chemical it came from, phenol. The other name for phenol was carbolic acid, and it got a surgeon called Lister all excited because it apparently disinfected cows. So in 1867, Lister tried dabbing it on his patients, and it worked. For the first time, a surgeon could make an incision and be pretty sure he wouldn't be committing murder. By 1871, Lister was squirting carbolic acid all over his hospital, thus giving every British surgeon from then on the chance to kick off any operation with that immortal gag, "Let us spray." Then, in 1893, a German engineer picked up the spray idea. You probably don't know him. Name of Maybach. Working with a better-known fellow called Daimler, whose sales chief had a daughter, whose name you certainly do know, Mercedes. Maybach put the spray carburetor he invented into the car named after the girl. The carburetor basically jets a fine spray of air and gasoline into the cylinder, where a spark plug explodes the mixture, and the explosion drives the cylinder piston up and down.
This up and down is converted around and round, thus moving the car wheels and anything else that needs to turn at high speed. Like the turbine fans inside the engine of the police chopper, spinning on a blast of air, superheated by a spray of burning fuel, driving the rotors and keeping the aircraft in the air.
So the chopper is here, thanks to the string of events that started back with anesthetic gas, remember? Okay, this chopper's run by computer. Now, the reason the computer was available to work out this entire SWAT scenario, one reason the computer exists at all, is because one day in August 1949, this happened. The USSR detonated their first nuclear bomb. The shocked American response was to set up an entire new defense system stretching the full length of the northern coastline of Alaska and Canada. A chain of over 50 radar stations called the Distant Early Warning Line, that from the beginning gave them 4 hours notice of the arrival of any Soviet atomic bombers, and then, as the system became more advanced, several minutes warning of an intercontinental ballistic missile impact. The signals from all the radar stations in the network were transmitted in real time to the new command and control center under Cheyenne Mountain in Colorado, where massive IBM computers analyzed every incoming track, identified the enemy planes, and automatically guided fighters to intercept them. There was one other bunch of people with the same level of vigilant concern for what was going on in America's skies at the time, American Airlines. Only their particular concern wasn't so much what a plane was, as who was on it. Or rather, wasn't. Because it was becoming painfully clear that airline reservation systems just weren't fast enough to keep up with the rapidly rising customer demand for tickets.
Fascinating thing about it is that an operator can access this.
And then one day in the spring of 1953, a senior sales representative from IBM happened to be on an American Airlines flight from Los Angeles to New York. In the next seat was a chap who turned out to be the airline's president. When both men discovered they were both called Smith, they got into conversation.
Can an operator connect?
It may have been one of the more meaningful conversations on an aeroplane ever, because of the way it affected virtually everything here in the modern world. Because it didn't take those two men back there long to realize that what IBM was doing for national air defense, linking a network of stations thousands of miles apart, synthesizing massive amounts of data from all those different locations, making it available to anybody with a terminal, acting on their instructions, and doing all that in real time, was, back in 1953, just what an airline reservation system needed to be able to do if it were to be ready for the jet age of the 60s.
Well, great. Let me get my people from Santa Monica together and we'll set
They
up-
agreed to take things further. 30 days later, IBM made a proposal. After 9 years of development, the new Sabre reservation system, as it was called, was up and running. Before Sabre, going flat out, it used to take you 90 minutes to book a seat. From 1962 on, you could book your seat and anything else you wanted for the flight, as you can today, in a few seconds.
So as soon as you get your date set, give us a call back. We'll be happy to help you.
Today, Sabre handles over 1 million passenger names every 24 hours. It processes 900 million telephone calls a week, sends 4,000 reservations messages every second, and deals with every other aspect of the airline's business at the same time. But the real reason an airline reservation system changed everything and generated places like this was because what Sabre had done was to bring the computer out of the military arena into the business world in a major way for the first time and show the business world the tremendous potential of what the computer could do for it. So, today, all over the world, places like this exist because of that one chance meeting on a flight in 1953.
Round trip or one way? Going out at 1:51 in the morning? Okay.
Down to 4500, man, 864.
Time difference will get you there at 1:35 in the afternoon into Newport. And you will get arriving in Chicago here at 5:35 in the afternoon, and you'll be departing at 10:35 in the morning.
Thank you for calling American. Bye-bye.
Cashmere shawls is what put IBM on that American Airlines plane. See, back in 1798, Napoleon invaded Egypt, and as soldiers have done throughout history, after a while his men started sending home souvenirs. In this case, the cashmere shawls that the Egyptians were importing from India. The shawls were traditionally made as marriage gifts, and they often took months to weave. They were supposed to be so fine they would go through a wedding ring. And the patterns were copies of ancient fertility symbols.
Anyway, fertility aside, the fashion caught on in Britain, where it kicked off a whole new textile industry in a place in Scotland called Paisley, where they started to turn out cheap cotton and wool imitation cashmere shawls for the lower end of the market. As a matter of fact, if you happen to own a Paisley pattern tie or scarf, that's where the pattern got its name. Anyway, in 1890, these Indian weavers had their products onto the American market. That same year, a young engineer called Herman Hollerith happened to be working on the US Census, and he was desperate for an automated way to count people. Now, his brother-in-law happened to be in textiles, and he told him about a new loom going around that would do cashmere shawl patterns automatically. It worked a bit like this. You take a piece of paper and put a pattern of holes in it, a bit like this pianola roll. Okay, you set up a bunch of wire hooks on springs, and you push the whole lot against the paper. Where there's a hole, a hook goes through and hooks up a particular thread. The particular thread you want for that particular part of the pattern. All of which makes weaving even the most complex stuff like this a piece of cake.
Back in the States, Hollerith used the idea of holes in paper to represent every kind of census data the government wanted. If you were a male married carpenter from Oshkosh, you got a male hole, a married hole, a carpenter hole, and an Oshkosh hole. Okay, you pushed a sprung, electrified set of wires against this card. Just like the cashmere loom, if there was a hole, the wire went through. It made an electrical contact on the other side. The signal worked an electric counter that added up the population. Did it so successfully, Hollerith went on to set up a business that later changed its name to International Business Machines. Now, the guy on the left here, the fellow called James Powers, was Hollerith's partner, and he designed a machine that would use the holes in the card to represent numbers for bills, inventory data, balance sheet totals, sales reports, that kind of stuff.
But the link to the SWOT exercise going on throughout this program was how you put the holes in the card.
With a 10-key punch like this one. I wonder if the design of those keys she's punching might remind you of something else you find in an office.
Like a typewriter? That's why in 1927, Powers took his idea to the Rand Company, the biggest office equipment outfit in America, selling over 4,000 office products from card indexes to typewriters. They bought a company that made typewriters.
The typewriter had been invented in 1867 by a fellow called Scholes, who'd based it on the idea of piano keys.
Anyway, in 1873, he took his prototype to a company called Remington, the company Rand would end up buying. And by 1888, they couldn't keep up with demand.
Now, Remington had bought the typewriter patent from Scholes just after the Civil War, when they were looking around for something else to do with the machine tools in their factories. During the war, the machine tools had been making something very different from typewriters. And it was something that brings us back for the last time to the SWOT exercise. Because
Remington had previously made the most successful military rifle in the world and sold over 1 million to armies in Denmark, Sweden, Spain, Egypt, France, and the US. So, finally, the weapon in the hands of this SWAT counter-sniper here is here because the computer is here.
Captain, the guy just indicated he's going to come out with the weapon and he's very hostile. He's going to take a shot.
I advise the perimeter that it comes out with the hostage, with the weapon. They have authorization for diversionary device, and a CS has the green light to take a shot.
Exercise safely concluded. Theirs and mine. And as I hope I've shown with the connections between anesthetics and explosives and engines and guns and computers, and as the SWAT team here would undoubtedly agree, getting it together is what it's all about.